Welcome to our physics tutorial. Today we're going to explore Coulomb's law, one of the fundamental principles in electrostatics. Coulomb's law describes the electrostatic force between two charged particles. It was discovered by French physicist Charles-Augustin de Coulomb in 1785. So what exactly is this law? Coulomb's law states that the force between two charged particles is directly proportional to the product of their charges, and inversely proportional to the square of the distance between them. Let's understand what each of these terms means. F is the magnitude of the electrostatic force between the charges. K is Coulomb's constant, which is approximately 9 times 10 to the 9 Newton meters squared per Coulomb squared. Q1 and Q2 represent the magnitudes of the two charges, and R is the distance between the centers of the two charges. Now, let's visualize Coulomb's law with a simple diagram. Imagine we have two charges Q1 and Q2 separated by a distance r. If both charges have the same sign, they will repel each other. If the charges have opposite signs, they will attract each other. An important concept to remember is that Coulomb's law is a vector equation. The complete vector form of Coulomb's law is where r hat is the unit vector pointing from one charge to the other. This vector form tells us not just the magnitude of the force, but also its direction. Let's look at an important property, the principle of superposition. When multiple charges are present, the total force on any one charge is simply the vector sum of the forces exerted by each individual charge. Now, let's examine how the force changes with distance. Coulomb's law follows an inverse square relationship with distance. This means that if we double the distance between two charges, the force becomes 1/4 of the original. If we triple the distance, the force becomes 1/9. Let's work through a simple example problem. Two charges, Q1 equals 3 microcoulombs and Q2 equals 5 microcoulombs, are placed 40 centimeters apart. Calculate the electrostatic force between them. Let's solve this step by step. Step 1. Convert all units to SI units. We need to convert microcoulombs to coulombs. Q1 equals 3 times 10 to the power of -6 coulombs. Q2 equals 5 times 10 to the power of -6 coulombs. And we need to convert centimeters to meters. R equals 40 centimeters equals 0.4 meters. Step 2. Apply Coulomb's law formula. We'll substitute our values into the formula. F equals K times the absolute value of Q1 times Q2 divided by R squared, where K equals 9 times 10 to the power of 9 Newton meters squared per Coulomb squared. Step 3. Calculate the force. Substituting our values. F equals 9 times 10 to the power of 9 times the absolute value of 3 times 10 to the power of -6 times 5 times 10 to the power of -6, all divided by 0.4 squared. Calculating this gives us F equals 843.75 newtons. Step 4. Determine the direction. Since both charges are positive, like charges, they will repel each other. So the force on each charge is directed away from the other charge. Therefore, the electrostatic force between the two charges is 843.75 newtons, acting along the line joining them, with each charge experiencing a repulsive force away from the other. Let's summarize what we've learned about Coulomb's law. 1. Coulomb's law describes the electrostatic force between charged particles. 2. The force is directly proportional to the product of charges. 3. The force is inversely proportional to the square of the distance. 4. Like charges repel, unlike charges attract. 5. It's a vector quantity with magnitude and direction. Thank you for watching our tutorial on Coulomb's law. Understanding this fundamental principle is essential for studying electrostatics and other areas of physics.